We already talked about strings in a previous video, and today I want to talk about how to handle those strings in Julia. Everything I will present today is already available from the official Julia documentation. What I want to do here is to present those information as a more beginner-friendly way. So what is a string really? Well, the official Julia documentation says that strings are finite sequence of characters, and the single character is defined using single quotes in Julia. So for example, if we want to declare A as a single character, we would put A between two quotes. And we can also use Unicode characters. So here, for example, we use alpha. And remember that to type alpha, we simply use backslash, type alpha, and then use tab to autocomplete into the Unicode character. And we can also use emojis in Julia, so this smiley face is a completely valid character for Julia. So I said earlier that a string is a finite sequence of characters. And we define strings using double quotes. So keep in mind that double and single quotes are very different things in Julia. So for example, if I try to get the type of a double quote of A, it's a string. But now, if I use single quotes, it's a character. And actually, we can think of a string a little bit like a vector of characters. So for example, if I index into my string here, and I request, for example, the first element of the string, I would get T, the first character of the string. We can also declare multi-line strings using triple quotes. So we have to start with triple quotes, then write our string and end up with a triple quote again. And we can see that Julia transformed the output and inserted a backslash and an N whenever there is a new line. And this is a standard used in many programming languages to declare a new line in a string. And of course, we can use this notation in a single line string to declare a new line. Another advantage of using triple quotes is that we can use quotes inside the triple quotes and it will be rendered as a string. And we see that the output from Julia inserted the backslash before the quotes. And this is a way to escape special characters. So for example, if we want to not have a new line here, we would escape the escape character. So we already saw that we can index inside a string. And for example, if we want the first character of the string, we would index by 1. And if we want the last one, we will index using the N keyword. We can also get the length of a string or get a substring from the string. So for example, if we want just the first word, this, we would index the first character until the fourth. And we can see that the output is still a string here. And what we can do also is getting a single character as a string and not a character. And to do that, we would index like this. So for example, if I index using 1 only, the type of first letter as string would be a character. And if I want it as a string, I would do like this. So this is a string. And if you want the second character also as a string, we will do like this. We can also use variables to make a part of a string. So for example, if we want a string that says x is equal to the value of x and y is equal to the value of y, we would use the $sign, which is called the interpolation operator because it interpolates the value of x or y, for example, inside the string. So we see that we declared x with the value of 1 and y with the value of 2, and they were put inside the string, the resulting string here and here, thanks to the interpolation operator $. So the clear advantage here is that if we update the value of x, the value inside the string will update too. And we can also interpolate the result of an expression instead of a variable. And to do so, we put the expression between two parentheses just after the $sign. And it will tell Julia that this is not a string, this is an expression that you have to evaluate. So Julia will evaluate the expression, take the result of the expression, and then interpolate the result into the string. So here, for example, x plus y equals 7. So we see that the $sign is a special character in a string. But what if I want to use the $sign inside my string as a regular character, not as an interpolation operator? Well, in this case, we can use the escape character, the backslash, just before the $sign. And it will tell Julia to use the $sign as a character and not as the interpolation operator. And here we see that the output of Julia keeps the escape character. But if we put it in a markdown, for example, markdown format like this, the escape character will completely disappear. disappear. Okay, so now let's concentrate on what we can do with strings. So for example, we can concatenate two strings using the string function. So here is our first string and here is our second string. And the string function would concatenate the two and make a single string out of the two strings. And Julia provides the multiplication operator as a shortcut for concatenating two strings. So if we multiply the first string with the second, we would get the same result as using string. We can also use the join function to achieve the same results. And it takes a vector of strings that will be concatenated together using a separator. Like for numbers, we can compare two strings. So for example, if we want to compare equality between two strings, we use equal equal. We can test for inequality, of course. And then we can also compare if a string is lower than another string, because A here is lower than Z. It appears before Z in the alphabet. And we have the lower or equal sign, greater sign, or greater than or equal than another string. We can also search for a character inside a string. So for example here, we want to find if the character O appears in school. And to do that, we use the find first function, which will find the first occurrence of a character that is equal to O inside school. And similarly, we can search for the last occurrence of O in school. So it will return 5 because it appears just after the first occurrence. And we can also find all occurrences of O in school, which returns a vector 4 and 5. We can also use the find first and all the other functions using a string as the first input, and it will search for the string inside the other string. So for example here, we search for the string is inside school is good, and it will return the position of the two characters here. So here the find first, find last, and find all functions will return the position of the first string in the second string. But what if we want just to know if it appears or not? And in this case, we would use the occurs in function. And so here we test, for example, if the string cat appears on the second string here, Oggy is my cat. We can also replace a part of a string using the replace function. So for example, the first argument is my original string, Oggy is my cat. And what I want to replace is the string cat inside this first string and replace it with wonderful cat. And the output is Oggy is my wonderful cat. And of course, if we want to replace not a string but a single character, we can do so using characters instead of strings. So here, for example, if I want to replace the T by an R, I would do T as a character replaced by R as a character. So now Oggy is my car. Julia also integrates very well with regular expressions, and regular expressions are quite complicated, but when you're used to it, it's very powerful. And regular expressions are a little bit like a sublanguage, and they are used to search patterns in strings using some kind of rules. And such rules can be really anything. You may want to search for a string that starts with a character and ends with another one, or have one character but not the other, for example. And usually regular expressions appear like strings, so to differentiate between a regular string and a regular expression, we use the little r before the double quote in Julia. So we can see here that because of the little r, the type of test is a regex, so it's a regular expression. If I remove the r, it will become a string. So this is not a course about regular expressions because it's a whole world in itself, but we can at least review the basics here. So for example, if you want to know if a string starts with something, you would use the caret sign. So in this example here, we declare a regular expression that starts with a caret and an uppercase O. And so what we want to test here with this regular expression is whether this string starts with an uppercase O. And because it does, the occurs in function returns true. What we can do also is search if a string ends with something. And to do so, we use the $sign. So note that in a regular expression, the $sign is not used as an interpolation operator. So if we want to know if this string ends with cat and a dot, we can use the $sign like this, with cat dot and dollar, to say that the string ends with cat and dot. But what I didn't tell you is that dot is actually a special character in a regular expression. So what we're doing here is kind of a mistake. So why Julia still returns true here? Well, it's simply because the dot character in a regular expression means any character. So what we did here is simply search if our sentence ended with cat and any character. So a dot is any character. And if we replace it with any other character, like an S, it will still return true. But there is a way to tell Julia that we want to match a dot and not any character. And to do so, we have to escape the dot, like we did before with the dollar. And to escape the character, the dot, we use backslash again. And now we see that it returns false because we are matching a string that ends with a dot. And it doesn't end with a dot anymore, but with an S. So if we replace the S by a dot, it will return true. If you want more information about regular expressions, you can look into the notebook. And you'll find more details about how to match things in strings. And I'll leave you with a taste of what a regular expression can look like when we are searching for complicated things. So for example, here we have this regular expression that seems very complicated and which in fact search for something that starts with a number of any number of alphabetical letters followed by an integer value greater than 2 and at least 2 number values between 0 and 9. And this seems very complicated, but when you're used to regular expressions, you start to better understand it. Keep in mind though that many people are just finding those information on the internet and it's completely fine to do so. And this video is part of a playlist, so if you want to follow them in order, you can go watch from that playlist. Thank you for watching and I see you next time.